By the end of this video, you are going to have an instance of Proxmox set up and ready to go, the core foundation of what it can do, how to use it, and why it's awesome. Whether if you're a complete nerd like me and you like to try to self-host anything you possibly can, or if you're a business looking for a great solution to host your containers, virtual machines, databases, whatever it may be. And if you don't know, Proxmox is a open source virtual machine management platform that allows you to create, of course, VMs, containers with their LXCs on either single servers, or you can even cluster a bunch of servers together. Proxmox is built on Debian Linux, so it is rock solid stable, and it provides you with a wonderful web-based user interface so you can manage just about everything, including all your containers, virtual machines, networking, storage, backups, and so much more. But first, of course, we have to consider the hardware that we're going to be installing this on. Proxmox works with any x86-based chip platform, so Intel, AMD, and I'll go ahead and throw the minimum specifications right here. But those aren't going to be that important because what's really going to matter is what you're going to want to do with this. Now, you can install this on just about anything, whether that be a single board computer like this Zimma board, you can install it on a mini PC like this little Intel NUC, or, and probably one of my favorite ways to do this is on a pre-built NAS, like this Ugreen here, as long as it doesn't have a lockdown operating system like Synology. I mean, you could even install this thing on an old dusty laptop, but in this video, what we're going to be doing is installing it on an old gaming PC I got. This right here is that old gaming PC, and believe it or not, this is a fantastic platform for Proxmox. We got an AMD 3700X, fairly powerful CPU, lots of cores. We got a Radeon GPU in here, 32 gigabytes of RAM. We have a single NVMe SSD with 512 for our boot drive. And then if you peek on back here, I actually threw in two 4 terabyte hard drives for additional storage, whether that be media, files, family photos, whatever. If there's just a couple lightweight surfaces that you plan on running, the power of the CPU is not really going to matter, but a big consideration is the type of CPU. So if you plan on doing something like Intel hardware transcoding, which involves when the CPU is in charge of downscaling video files for something like Plex or Jellyfin, Intel is definitely going to be a really good option, as Intel QuickSync is a great platform for that purpose. So something like this Intel NUC will be great for running a media server. If I wanted to use this thing as a media server, it might be a good idea for me to get a cheap Intel Arc GPU and throw it in here. Another key consideration is the storage. For example, this Intel NUC right here has 2 NVMe slots and that's it. So what I would probably want to do is get 2 matching NVMe's of the same size in the largest size I could afford, set them up in a ZFS pool for the initial installation, so then if one of these drives fails, I could easily swap it out. I only got 1 NVMe hidden in there, so I'm not really going to be able to do that, so setting up a separate instance of Proxmox backup server in the future is probably going to be my ideal situation. And then the last thing to consider is your actual NIC. In a vast majority of cases, 1 gigabit is going to be fine, and most cases your network will only support up to 1 gigabit, but if you got some good networking equipment, getting a 10 gig NIC is awesome. And if you plan on doing something like running maybe OpenSense, pfSense, or some other firewall on Proxmox, installing additional NICs is really good way to go about it, because then you can dedicate NICs to specific virtual machines. Ultimately, there's a lot to consider. If you need any help, go ahead and leave a comment down below. I'll try to get to it as soon as I possibly can. I could keep going and going if I wanted to, but we don't have time for that, because what we need to do is actually install Proxmox. And doing that is actually very, very easy. All we need to do is go over to the Proxmox website, head over to downloads, and we have Proxmox VE right here. That's what we're going to want. We're on version 9. We're going to download that. There we go. While it downloads, go ahead and find yourself a good old USB flash drive, because that is going to be our boot device. And there's a number of tools that you could do or use to flash a USB. For example, in Balena Etcher, all I do is flash from file, select good old-fashioned Proxmox, select the proper USB flash drive there, flash, input our password, and then we are good to go. Now, depending on the motherboard manufacturer of the device that you're going to be installing Proxmox onto, the key to get into the boot menu may be a little different. You might have to go ahead and look at the manual, whatever. Usually it's F11, F12, escape, delete, something like that. Maybe even F2. I don't know. Now, all BIOS are a little different. You may have to change some settings in your BIOS. For example, here in the boot menu, you may want to turn off fast boot. You're going to want to turn off secure boot. And depending on if you're running AMD or Intel, you're going to want to turn on whatever virtualization support there is. But for now, all my settings are good. So we are going to go over here to our boot option, and I'm going to change this to the USB drive, head over, save changes and exit, and then allow the system to boot into that USB. Which here we can see, welcome to Proxmox virtual environment. Let's go ahead and continue here with the graphical installer. Give that a minute to boot in. All right, there we go. I don't have a mouse, so I'm going to be using the keyboard here. Go ahead and use that in-license agreement. Agree to it if you do. And then the first option is going to be the hard disk that we want to install this on. Again, I only have one NVMe SSD in here, but if you do want to set up some redundancy, I would highly recommend you throw two of the same size in there, set up a pool. And how you would kind of set that up is, for example, here I have my NVMe, but I also have two spinning disk drives. Don't use a disk drive as the boot. But just as an example, if I went over to options here, this is where I could go ahead and select ZFS. You can see I have RAID 0, RAID 1, and we have all the RAID options, so you can have a whole bunch of drives act as your main boot drive if you'd like to. But I would just select ZFS, and then here I would select the two disks or the two NVMEs that you would want to use and continue with that installation. But for my boot drive, I am just going to go with ext4, continue, and go with that one NVMe that I actually have. So we'll go next, select your country, and then of course your time zone. So I'm in Los Angeles, and then go ahead and go next. Now here is a password. Make it as strong and secure as you would like it to be. The stronger the better. This is a security company after all. So pop in your email, go ahead and go next. Now here, this is the networking setup. I mentioned that you want to have that plugged in before you get into here. So then it will automatically detect your main interface that you want to go ahead and use. Now here, the host name is relatively important. This is what your node is going to be named. A node is the actual instance or server. PVE is the default. Since I'm doing this as kind of a demo, I'm going to call this Bird Box because it's for NetBird. This local IP address looks fine here, so we will go ahead and hit next. Gives us a rundown of everything that we got going on here. So we are going to just hit install and then let that do what it needs to do. Hey, look at that. You saw that? It finished. It flashed real quick. Please remove the boot media. Will do. And now it is rebooting. And you can see we have the Bird Box login right there. And we have our little URL. So this is going to be ending at 246 with our port. So that's going to be 10.0.246. Obviously, probably going to be a little different for you. At 8006. And of course, we cannot forget that this is HTTPS. Hit enter. We're going to get a little warning. This is our server. We don't really need an SSL certificate, at least as of yet. But let's show details. Visit this website. Visit the website. And here we go. We can now log into Proxmox. So to log in, it is just root and then the password that we set up during the installation process. And then we could go ahead and log on in. And there we go. This is our first look at Proxmox. We can see our Bird Box right here, which is indeed this server. And just for a little tour, down here we have some of our tasks and information. So you can see we already have gotten an error for apt-get update, which we will get into. Over here, this is your sidebar of everything, our data center, our machine. We have our storage and networks. We have our local network right here. Oop. There we go. And we have two things. We have local and local LVM. Again, I'll cover that in just a moment. If we go into our data center, on this sidebar, we're going to have all the aspects of the entire environment, including the backup, all of our storage, various options, our users, tokens, all the permissions, and a whole lot more. And if we click on our specific node, then we'll get only the stuff related to this specific server, such as our DNS setup, the shell instance for this server, the disks that are actually in this server, and again, much more. And of course, if I scroll up, we go to summary to see the CPU load, RAM, hard drive space, and all of that. Now I will note some of what we're about to do can be achieved with a helper script. The post install helper script can fix the repos and do a couple other things. But for this video, I'm going to show you how to do some of this manually because we do want to update our system. So what we could do is go over here under updates, repositories. You can see we have some warnings here. The enterprise repositories are enabled, but we don't have an active subscription. If you want to subscribe, go ahead and do that. But I don't want to at this moment. So we have two enterprise repositories right here. I am going to disable this one first. So let's disable that. and then we'll go ahead and disable this enterprise repository. And now there are no repositories. We do want a repository. So I'm going to click on add. Right here, I have no valid subscription. That is okay. And I'm going to hit this drop down. I am going to add both the no subscription repository as well as the Squid no subscription repository. So now that that has changed, and then go over here, click on updates. We're going to go ahead and give that a moment. We could click refresh again if we would like to. That's just going to run a apt-get update. Task is okay. And now we can actually upgrade our system. So let's confirm that and let it do what it needs to do. And there we go. The update is complete. It says, please consider rebooting to activate the new kernel. And let's go ahead and do that. So we could go ahead and close this out. And right here with our node selected, we could just hit reboot and we could reboot the nerd of Bird Box. Yes. And then give that a couple minutes to succeed. And it looks like the reboot is successful. So if I give this page a refresh, we should be in. Refresh our updates, make sure there's nothing else, in which there is not. So our system is now fully up to date. Now, one thing you may have noticed is over here under summary, I only have about 100 gigabytes of usable space. However, this is a 500 gigabyte hard drive, and that is because of LVM. Now, LVM is great. If you do have a larger boot drive, or if you plan on adding additional storage and using the other storage for your LXC containers, virtual machines, and just data storage in general, I recommend you keep LVM and skip this part of the video. LVM provides the benefits of pretty nice snapshots, storage over provisioning, and flexible management of virtual disks. But if you're limited on your storage, having it partitioned out like this might not make sense for you. Right here, we can see our local and our LVM partition, and here you could actually see what these are specifically for. The LVM is assigned for disk images, virtual machines, or containers, and this is the larger partition. Then under local, this is specifically for ISO images, backups, and container templates. And this can be changed. If we head over to our data center under storage, you can see we have our local and our local LVM with the content right here. If you wanted to edit this, you can edit local, for example, and let's say you wanted to remove backups from here. That is an option. So now this local partition will not handle backups anymore, or we won't have the option to use it for backups. Now, if you wanted to remove this LVM partition and use just one partition for everything, first we would assign the disk images and containers to local. So let's edit this and then add containers and disk images here, hit OK. And then we would completely remove this local LVM. Another important note, only do this on a fresh boot. If you already have a bunch of stuff going on, just leave this alone. So we can remove that, hit yes. So now we only have the local there, but it only has, if we go over here under summary, 100 gigs of storage. So we're going to need to expand it. And to do that, we're going to go over to our shell, and then we're going to run the following commands. The first is a lvr remove data. Hit enter, yes. Again, don't do this if you have a bunch of stuff on there. And then we are going to do a resize of our local partition here, which is under dev pve root, hit enter. And then finally, we're going to do a resize 2fs command of dev mapper pve root. So now if we go back to summary, you can see that we now have the full available space for our hard drive or our SSD. Now something we're going to want to make sure is enabled is IOMMU. Input-Output Memory Management Unit. You're going to want to enable this if you ever plan on using a PCI pass-through for like your GPU, for example. Enabling this does better performance, lower latency, so on and so forth. And this is going to be a little bit different depending on the actual GPU you're running. I have an AMD machine, so we're going to run through that. With Intel, there's only going to be one line you change. It's pretty easy. So within Bird Box, we're going to go back over to the shell here. We're going to drop in this nano etc default grub. So we're editing our boot options here. And then right here where it says grub, command line Linux default quiet, we're going to add a little bit here. Do a space. And if you're running Intel, you would do Intel underscore IOMMU on, but I am doing AMD, or I have an AMD machine here, so we're going to do AMD. Simple as that. So let's output that, exit out. We are going to run a update grub command, and there we go. So now just to give a little example, before I reboot, if I run this, you can see I get no messages with this command. And if I run this grep command here, it says it doesn't support it. So again, with my node selected, I am going to reboot my node. Jumping into our BIOS real quick, we're going to make sure that this is enabled. So under advanced, we'll go to CPU configuration, and you're going to want to make sure SVM is enabled. Additionally, under advanced, we're going to go to AMD CBS, and then the NBIO common options. And right here, see, we want to go ahead and make sure we enable IOMMU. And sure, let's go ahead and enable this, auto, and we'll auto that as well. So now, with those changes made, we can save our changes and exit. So now in the terminal here, if I run these commands again, we could see that it's supported. And then if we run the grep remapping, we can see that mapping is enabled. We do have a little error here. Remapping doesn't support X2 APCI mode. Never seen that before, which based on my limited amount of research here, if it doesn't encounter a problem, ignore it. If it does, disable it in the same place in that grub command line that we enabled IOMMU. So do note that. Now that that's enabled, later on, it will be much easier to set up GPU pass-through and things like that. Now, how do we use those two hard drives that I put in here for additional storage? That is what we're going to be setting up right now. So in our bird box, if I head on down to disks, you could see we have our NVMe right here. This is our main boot drive with Proxmox on it, but we have these two 4 terabyte drives. Now, what I'm going to do first is go ahead and wipe them. So if I wipe the disk, yes, give that just a sec. And then let's wipe this disk. Yes, give that just a sec. And I'm going to set this up in a mirror like I kind of demoed a little bit with the initial installation. But the more drives you have, obviously the more storage you'll have, and you'll have options to pick different RAID configurations. There's calculators, there's all kinds of things that you can use to kind of figure that out. We're not going to dive into that in too much detail in this video. We're just going to set up a simple mirrored pool. So once we have those wiped under disks, again, we're going to go over to ZFS. Again, the more RAM you have in your system, the better that this will perform. But at 4 terabytes, only 32 gigs that I have in here should be sufficient. What we're going to do is create a new ZFS pool, and we're going to call this something like tank. This is my tank storage. And we're going to select both of these drives here. Make sure to keep add storage selected. Here under RAID level, you could do a mirror, which is what we're going to do. We go ahead and keep compression on, just keep the default, looks good. If you do want to specify, LZ4 is a generally recommended option, but I'm just going to keep it at on, and we are good to go. So let's hit create. Give that just a minute to run and create that pool for us. And now you can see tank there, and it is also showing up right here under our storage. We have just about 4 terabytes available to us. Life is looking good. Now, if I go under data center and storage, where is it? There it is, storage. You can see by default, it is assigned for disk images and containers, which is perfectly fine. So now when we go ahead and create our containers or virtual machines, we'll have the option to add additional storage with tank. You can install machines directly on it, but do note it is running off of spinning disk drives, so there may be a performance decline as opposed to running it on NVMe. So what I generally do is I install the root file systems on NVMe, and then I use tank, for example, for additional storage, for media storage, files, things like that. Which now we have a pretty good established setup here. We have a lot of the prerequisites out of the way. We're ready to actually do some things. And the first thing that we're going to do is install run our very first container, which again, there are 2 ways to do this. We have containers and virtual machines. Now containers are awesome because it shares the kernel with the host system. So they're incredibly lightweight on resources. You could kind of think of them like Docker containers. It's an isolated instance sharing resources with the host. There are pros and cons to that. For example, it's not really recommended to run Docker containers in these containers. If you're going to run Docker containers, it's recommended to do that in a virtual machine. And to set up things like Intel QuickSync pass-through or even the network tunnel, it requires some additional configuration within the terminal, which we're actually going to touch on in our example here. For our first container, this is going to be a NetBird peer. And this is how we're going to connect to both this Proxmox machine and any machines on our local network remotely from anywhere in the world. And at the moment, I do recommend installing NetBird on an LXC or even a virtual machine because there seems to be a conflict with the Proxmox DNS settings and how it works and how NetBird likes to use it. So it is recommended to kind of isolate this a little bit. So the first thing we're going to want to do before we create our container is we're going to need to grab a template. And to do that, we're going to head over to our local storage here under container templates. And if we just go ahead and click on templates, we have, a bunch of them. So you can pick what you generally prefer. We have a bunch of turnkey stuff with things pre-installed on it. Maybe in the future we could get a turnkey NetBird instance. That would be cool. But for now, we are just going to go with good old Ubuntu. I'm going to go with the 22.04 version. You could go with Fedora, you could go with Debian, whatever you want. But I'm going to go with this version of Ubuntu, click on download, and then that container template is going to download into our local storage so we can use it now and reuse it in the future for more containers. So there it goes, it is downloading and the task is done. So let's go ahead, close this out. And now with our container template there, we can click on create container. It's going to bring up a pop-up box here. We have it on the NetBird box. This is going to be our NetBird LXC. We're going to keep it as an unprivileged container. It's best practice to have all your containers as unprivileged, but depending on what you want to do, it might be a good idea to create a privileged one. If it does have privilege, it can access basically anything on the host, which generally isn't always the best idea. Create a password. I'd rather pick and choose what a unprivileged container can access versus just doing a privileged one. So from there, let's go next. Under our local storage, we're going to pick that Ubuntu template we grabbed. And then for disks, our root file system, again, we have the option to put it on tank if we'd like to, but then it's running off of spinning disk drives. So I am going to put this on local. We're only running NetBird on it, so size doesn't really matter. 8 is going to be fine. I'm going to give it an extra core just so it downloads and updates a little quicker. And for memory, let's go ahead and give it a gig. For just running NetBird, 512 is more than enough. But we're going to go next. We're going to set IPv4 to DHCP. So then our network router or modem is responsible for assigning this an IP address. Keep all these as is. You can enable IPv6 if you'd like to, but I'm going to go next. We're going to use the host settings for DNS. Go next. Here's a little rundown. We're going to go ahead and click on finish, and then you can see it created and it is done. So if we look over here, we can see our very first container with the ID 100. It is NetBird LXC. We can see a summary of everything we got going on here, and you could go in and just change basically anything that we just did. So for example, if I went under resources and I wanted to add additional storage with the tank pool, what I could do is add a new mount point, set the storage to tank, and maybe we just wanted a straight up data mount point within this LXC. For this, I would disable backups. We could give it a size. We have about 4 terabytes, so I could assign 1,000 to this if I wanted to, and then we could create that. And now that's an example of how you'd go ahead and use your ZFS pools to add additional data within these containers. Additionally, we have our network settings here, DNS, we have some options that you could go ahead and change, backup, snapshots, and a whole lot more. Now, one thing I need to do, because NetBird requires access to the host tunnel device, DevNet tunnel. And theoretically, we should be able to add it as a device pass-through right here, but there's some additional little options that will make this run much better. So to do this, we're actually going to go over to Birdbox and go into the shell real quick. And I'm going to show you where the configuration files for these LXC containers are. So if I went into the directory for Etsy and PVE LXC, just like that, run an ls, you could see a 100conf file there. That is the configuration file for this container. It's offline, so I could go ahead and edit it. So if I nanoed into that configuration file, you could see a lot of the information that we set up during the setup process. We have the cores, we have the host name here, we have the memory, we have our root file system mount point, which is under local, and then we have the mount point that we added, which is under tank and a subvolume, OS type, networking, swap, and the privilege. Now here you could add additional configurations. For example, if you want to do Intel Passthrough, you would probably want to add it here. Or if you want to create mount entries. So I am going to drop these lines right here. We're adding some permissions for the devices that we're allowing, and we are creating a directory mount point entry for DevNet, and then we're creating the file mount point entry for the tunnel. NetBird needs this to run efficiently, so we're giving it access to that from the host. So output that, Control X to back out of there. And now I'm going to go ahead and start up this LXC container. So if I go ahead and click on start and then head over to the console, you could see we're ready to log in. By default, if this is going to be root and then the password that we set up. So now we're in, and you can see that if we ls into dev net, we can see that tunnel device there. And if I wouldn't have added those entries, that would not show up. So before we add NetBird to this for remote connectivity, we are going to update our system with a sudo apt update and a sudo apt upgrade. Yes, let that run. Ooh, we have a lot of updates. This is going to take a minute. That's really the only reason I upped the CPU and RAM is for kind of this initial update here. Hey, it's updated. The other thing we're going to want to do, the NetBird installation script uses curl. The containers, or these container templates, are usually extremely lightweight, so they are basically bare bones. So we're going to go ahead and apt install curl real quick, just like that. There we go. And now we are going to head over to the beautiful netbird.io. Click getting started here. If you don't have an account, it will take you through a really nice onboarding process in which you can kind of set everything up there. But I'm just going to log in real fast. And then here is all my everything. So if I just head over to setup keys, it's real easy to get a peer connected here. So let's create a new key. And then this is going to be our bird box. Now you can make it reusable if you want to. I'm only doing the one machine. I'm also going to throw this in a group. This is going to be, I'll just throw this under Office Resources. So this is an Office Resource device. Let's create that setup key. And here it is. Now instead of copying the setup key here, I'm just going to click install NetBird. And we have our curl command right here under Linux. Of course, if you're doing this Windows, macOS, Docker, there's a wide variety of platforms that you could go ahead and install this on. But I'm just going to copy this curl command, head back over to our bird box, paste it on in, hit enter, and let it do its magic. It's a pretty small application, so it will take no time at all. While that finishes running, we are going to grab this run command, which includes the setup key that we just generated. So give that a copy, head on back over here, and you can see the installation process was successful. So if I go ahead and run this, hit enter, usually only just takes a couple of seconds, and we can see that we are connected. So if I run a netbird status-d to get all the deets, all the details, we can see our NetBird IP address, our relay signal servers, and everything else that we have available to us here. And that's how you set up remote connections. So if I go back and then go over to peers, we can see our NetBird LXC right here ready to go. And then if I wanted access to it, I would make sure that my user has access to Office Resources, which I'm pretty sure I already do. All that is done under access control and policies. So yep, IT administrators, access to Office Resources, two-way connection. So we're good to go. You can always check your user by going under team, users, go to yourself, and you could see what groups you're a part of. If you do want to learn more about NetBird and how it works, there'll be a video linked right here going over the entire architecture, and check out more videos on this channel to learn much more about all the features, use cases, and really everything that you could do with it. But how I have this set up now, if I installed the NetBird client like I have on a computer, such as a laptop or on my phone, I would be able to access my Proxmox instance from anywhere in the world. That I have an internet connection, of course. So that is creating an LXC. Now this will just run, keep running. Let's go to options and make sure that this starts on boot. So if our system reboots, this container and NetBird instance will also reboot and we will maintain connectivity. Additionally, to access other resources, so if you had other servers on your network or other devices that you want access to, you do that through networks here. So if I open that up, all I would do is add a network. So this is my home office. I would add that network, add a resource. And for this, it would be our subnet for our office. You'd then put in your subnet IP address for the destination group. I think I already have a subnet, so main office subnet here, add that resource. And now for that resource, I'd go ahead and create a policy. So the main office subnet, I want my IT administrators, which is me, to access that. So just like that, that's fine. If I had more users and I wanted to set up like real granular control of what exactly people can access, that's where I would change this to like TCP, assign specific ports for policies. But for this, we could just go all continue. We're not going to do posture checks for now. And subnet policy, add that policy. We're going to add a routing peer, which is going to be that Proxmox device. Show, if I go down here, this is our NetBird LXC. We'd continue, enable that routing peer, add the routing peer, and there we go. So you can see our home office right here. We have access to the subnet. Using this routing peer, if you add more peers, you enable high availability. But now I'm getting real too far into the weeds for this video. So we're done with NetBird for now. And lastly, we have VMs, virtual machines. I love to use virtual machines for two key reasons. One is I usually use like Ubuntu server and run a bunch of Docker containers within a VM, or I use it for like running Windows. Because I don't like Windows, but it's nice to have access to at least a Windows VM for Windows type activities. But for the sake of time, I'm going to set up a Ubuntu desktop in a virtual machine. And to do that, it's as simple as creating a VM right here. The VM ID, I'm going to change this to 200. I kind of like to separate these out like that. This is going to be a Ubuntu desktop machine. So let's go next for the image. Oh no, I forgot to upload an image. So just like with containers, we're going to head back over to local, go over to ISO images, and you could either download directly from whatever website, or you can upload an existing image on your computer. So let's go ahead and select the desktop ISO and uploader right in there. So let's go upload and then just give it a little bit of time. And boom, just like that, we got Ubuntu desktop ready to go. So let's close this out. And now we can create our virtual machine. So let's create VM. Again, this is going to be Ubuntu desktop. And again, I usually use this for headless Ubuntu servers, but you can do it however you prefer. Let's go next. For the OS, we're going to select Ubuntu right there from local. This is Linux, and that is the kernel version. So we're just going to keep everything here as is. Go next. And here, we're going to keep everything as default and then add pass-through later, so then we can utilize the GPU for various tasks. So I'm going to keep default. There's a lot of options here, but default will kind of be the best for standard VGA, so we can access it remotely through Proxmox. All this looks good. Let's go next. For disks, this is our boot drive here. Let's give it a little more storage, maybe something like 64. And if you want to, you can add additional storage directly through here. So if I click on add, go to SC1, I can change this to be in tank. And here, for example, I could give it another terabyte if I wanted to. And then that storage will be mounted to this virtual machine. So from there, let's go next. Let's give it some cores. It's Ubuntu, so let's give it at least 4 so it runs well. 2 gigs is fine, but I'm going to go ahead and up it to about 4 gigs. And then we go next. We're going to go ahead and bridge the device. That is fine. Next, and then confirm. This time I'm going to start after created so we can go ahead and just dive right in. If I click on this 200 right here, head over to the console. This is going to be no VNC. So then we can proceed to install Ubuntu using this. So there we go. Now we have the graphical interface here. We're going to go ahead and wait for this to prepare. There we go. So we'll just run through this installation real quick. I'm not going to go through all this. Now here I will note for the hard drive selection, we do have both of the hard drives. So I'm going to go with this one right here, the smaller one, since it is that NVMe. Let's go next, fill all that out, go next, and then install it. And there we go, just like that, it is installed. Instead of restarting, I'm going to completely shut her down. So let's hit up here, go power off, and power her down. Go ahead and hit enter here, and it's shut down. So what we're going to do, 2 things real quick. First, we're going to go over to hardware, and we could go ahead and ditch this ISO. So let's remove the disk here because we're not going to need it anymore. It's already installed. And let's go under options. And then right here where it says IOMMU guest agent, we're going to want to enable that. So let's click on that, click edit, and use the IOMMU agent. It says to make sure it's installed on the VM. We will do that. So let's hit OK. What this is going to do is allow the VM to communicate with Proxmox a little bit better, such as doing proper shutdowns, being able to freeze the system during backups, snapshots. You'll have a better VM experience. So let's go ahead and start this up and install this on our guest machine. So we're going to boot into Ubuntu here for the very first time. And let's go ahead, get through this real quick. Next. No, we don't want Pro. Sure. Finish. And now open up a terminal, and we're going to want to install these agents. So sudo apt install IOMMU-guest agent, just like that. hit enter, type in your password. You can see the packages. We are going to say yes, and there we go, it's installed. Now we probably should have ran a update and upgrade first, but this works. Forgot to put apt in here, my bad. There we go. I'm so used to running as root, you know? There we go, it's updated. And we're basically ready to go, but one thing I do want to touch on real quick is the GPU pass-through. How do I make a GPU usable by this VM? Do this, first let's go ahead and shut her down. So let's shut down this VM. And I am going to reference this documentation right here, and this will be linked down below. We've already done the first step, which is enabling IOMMU, and the next step is to actually do the GPU pass-through. The first thing you're going to want to do is blacklist some drivers, basically making it so Proxmox itself won't try to utilize these drivers, as this device is going to be completely passed through to the VM. We don't want Proxmox and the VM trying to conflict with each other and use this device. So since this is an AMD GPU, I'm going to blacklist the AMD drivers. If you threw in a NVIDIA GPU, you'd blacklist those. Head over to the shell for Birdbox, and I am going to blacklist these drivers with some echo commands. So echo blacklist AMD GPU, just like that. And then we are also going to do Radeon, just like that. So now I'm going to go ahead and reboot this entire node. So let's say yes, reboot the bird box. And it looks like our system has successfully rebooted. So if I give this a refresh, we're back in. Now to actually pass through that GPU, if I head over to Ubuntu desktop here, don't start it up yet. We're going to go to hardware. I'm going to add a PCI device. Now here, I don't have any mapped devices showing up. So I'm going to go raw device. And here we have a whole bunch of stuff. What I am going to want is this right here, number 3. This is the Radeon RX, specifically this one's a 580. And do make sure you select the right one. For example, this ID of 500.1 is only the HDMI audio. I want the 0.0, so it's the entire thing. I'm going to check all functions here, and I'm not going to check primary GPU. If I check that, I won't be able to see it with no VNC. There are use cases where you'd want to use it as your primary GPU, but for now, I'm not going to do that. So let's click add, and then we have the PCIe device right here. So now if I go ahead and start this machine up, we still have the display at default. So if I go to the console, we should still be able to log in and check everything out. There we go. Let's log on in here. And now we should be able to see our AMD device. Let's jump into the terminal. I think NVTop is something we can use. So sudo apt install. There we go. Now if I do NVTop, there it is. You can see we are now in this virtual machine, and it is monitoring our AMD Radeon RX 580. I don't have it doing much here, but if I wanted to assign it to be like the gaming GPU for this machine, or mining, maybe using it to run a language model, do some AI, that is a great use case for this. So that is really about it. We can also check real quick. Let's see if our other disk has showed up. So disks, you can see we have that 1 terabyte right there. And then if I want to actually use it, I would just go ahead and format this disk just like so. Click format, type in our password, add a new partition, go next. This can be storage. Linux file system is fine. You'd create that. Give it just a sec. I heard some movement in the machine, and now you can see right here, we have storage. If I open it up through here, under other locations, we have our storage. So that's about it. Quite a bit we went over. I hope you learned something. I hope you follow this video and enjoy Proxmox setting it up, whether if you're using it for professional uses or if you're experimenting, playing around. It is one of the best environments that you can use in your home lab to experiment, spin up some services, and just really learn the power of Linux, networking, programming, so on and so forth. It's a fantastic tool, and I do hope this has helped you out. There are chapters down below, so do not hesitate to come back to this video to go to a section, to redo something, whatever you need to do. And of course, this is NetBird. Do check out netbird.io to learn about how you can use NetBird to connect to either specific servers or your entire network from anywhere in the world. And with all that, do subscribe to this channel so you can see our future videos and more videos like this. Have a beautiful day, and goodbye.